Alright guys, we're going to do 3 tests today. The geometric series test, the nth term test for divergence, and the telescoping series test. So as a quick recap, from sequences converge if a limit exists. But when you have series doesn't necessarily converge just because a limit exists. So that's why we have to do all these different tests to see if the sequence will end up, when you add them and it becomes a series, if it will converge. The first one we're going to start with today is the geometric series test. The geometric series test, you should already know. We kind of did that in class yesterday. A geometric series is one where you multiply by the same number every single time. You'll see 2 types of geometric series. One where you're starting at 0 and you just have to the nth power, or one where you're starting at 1 and you have to the power of n minus 1. It doesn't really matter which series this one looks like. It's the same thing, only you start with the lesser exponent here than you do here. The only thing that really matters is that A1 term, remember, that's the first term. And we kind of talked about that last class. So if you're starting at 0 for your series, make sure you plug 0 in for this for this sequence, and then you use that term as your A1. Okay? So a geometric series will diverge if R is greater than 1, and if R is less than 1, then the series converges. Okay? Absolute value of R. So you should remember that. If R is greater than or equal to 1, the series diverges. If R is less than 1, then the series converges. And this is the sum that it converges to. Most of the time, you're not going to be able to tell me what the sequence converges to. The only one test that you can use and tell me what the series converges to is the geometric series test, and then sometimes the telescoping series test. But most of the time, it's just the geometric series test that you can figure out whether or not, or what number it converges to. Okay? All right, let's do example 1. And it just says, determine whether the following series converge or diverge. So I can rewrite this sum as 3 times 1/2 to the nth power, right? And if we look at this, my R is going to be 1/2, which is less than 1. And if it's less than 1, and we look up here, if R is less than 1, the series converges. So this converges. And we can actually figure out what it converges to. So we take 1 and we plug it into this function. So 3 times 1/2 to the first power is 3/2 over 1 minus, our common ratio is 1/2. So we get 3. Okay? So this this series will converge to 3. The series converges to 3. Now we have another case here where the 3 is now inside of the parentheses, so the 3 is also to the nth power. And if you look at this series, R is going to be the whole thing of 3/2 which is greater than 1, and since 3/2 is greater than 1, you can automatically say that this series diverges by the geometric series test. And you're going to have to state which test you're using to prove that it diverges. And you also want to state that r is less than 1 as justification. Right? So geometric series test, pretty easy, and you can actually figure out what the sum converges to. The next test is called the nth term test. And the nth term test only tests divergence. So that's something that you need to be on the lookout for. The nth term test will not prove convergence. So you need to make sure that you're only using it to prove divergence. And 99% of the time, I look at this test first. So I make sure, and I try this test first before I try all the other ones, because if I know that it automatically diverges, then I can just stop. But what you're going to have to do is you're going to have to look at it and see if the limit of the sequence goes to 0. If the limit of the sequence goes to 0, then the series diverges. Oh, I'm sorry, I said that backwards. If the limit of the sequence does not equal 0, then the series diverges. All right, so that means, that makes sense though, right? If you have a sequence that converges to, let's say, 1/3. If you have a sequence that converges to 1/3, and as you go on to infinity, you're adding 1/3 every time, is your series going to converge? No, your series is not going to converge. So you have to make sure that your sequence actually goes to 0 in order to even attempt to see if this series converges or diverges. So if your sequence, or if your limit of your sequence does not equal 0, then the series will automatically diverge. All right, make sure though that you do not use the nth term test to prove anything about convergence. So this does not say that if the limit of the sequence goes to 0, then the series converges. This test can only be proved used to prove divergence. Okay, so you can only use this test when you're proving divergence. If the limit equals 0, this test doesn't tell us anything. It just means that it could converge, it could diverge. We're going to need to use another test. We need more information to prove whether it converges or diverges. Okay. All right, so if we look at these 3 examples, and remember what I said, I always start with the nth term test and see if it diverges automatically, and if it does, then you can stop. So for every sequence, I start by doing the limit of the sequence. And this limit, if we do L'Hopital's, or if you just evaluate horizontal asymptotes, will equal 2/3, right? All right, so if the limit equals 2/3, then that means that the sequence is going to go to 2/3. But if the sequence goes to 2/3, then the series is technically adding 2/3 every single time as you go to infinity. That means that the series is going to diverge by the nth term test. Okay, so you would just say that the series diverges by the nth term test to prove whether it converges or diverges. All right. For B, let's evaluate the limit again. Limit as n goes to infinity of n factorial over 2n factorial plus 1. And remember, as you go to infinity, the plus 1 is inconsequential. And then we have n factorial over 2n factorial. So this limit is going to go to 1/2. And since the limit of the function goes to a number other than 0, we would say that the series diverges by the nth term test. Okay? Last one, let's evaluate the limit. So this limit goes to, the 2 is inconsequential as you go to infinity, so we have 3 to the n over 3 to the n. This limit is going to go to 1. So same thing as all the others, this does not equal 0. We can automatically say that the series diverges by the nth term test. Okay? All right. So quick recap. We've learned 2 tests so far. We've learned the geometric series test. If r is greater than 1, the series diverges. If r is less than 1, the series converges. And for geometric series, we can figure out the actual sum of the geometric series if the series converges. The second test that we learned was the nth term test for divergence. If the limit of the sequence does not equal 0, then the series automatically diverges. Because remember, you're adding that limit. If it's not equal to 0, you're adding that limit every single time. And if you add that limit every single time, then the series is going to go to infinity. Don't forget, the nth term test is only used to prove divergence. It's not used to prove convergence. So you can only use this when you're trying to say that the series diverges. It's a good test to look at every single time you start a series problem to say, hey, maybe I could use the nth term test to prove divergence and I wouldn't have to do any more work. But remember, nth term test never proves convergence. All right, and then the last test that we're going to do today, and then I'm going to let you work on your homework. As I said, I would keep this video pretty short and let you enjoy your day. But what it's called is the telescoping series test, because it collapses to one term or to a few terms. So don't forget, this test is only used when the series will end up canceling each other out. Okay, so you can prove convergence by the telescoping series test. It's not really used crazy much in BC calculus, but it's something that you should know. Usually what happens is you'll see a fraction minus another fraction, or you'll see something where you can do partial fraction decomposition to separate 2 terms, and then it ends up canceling. So if you see something that can be decomposed, or something that has a series that has 2 fractions, then you might be doing a telescoping series test. Okay? So if a series collapses to a finite sum, then it converges by the telescoping series test. For example, if you look at this problem up at the top, you have 1, and then you have minus 1/2, and then the next 2 terms are 1 plus 1/2 minus 1/3. The next 2 terms is plus 1/3 minus 1/4. So you see that the negative 1/2 and the positive 1/2 end up canceling. And then the minus 1/3 and the plus 1/3 end up canceling. And the minus 1/4 and like the next term, the plus 1/4 would end up canceling. So as you went to infinity, you are only left with a few terms. And the few terms that you're left with in this one is just a 1. It's not always like that. You might have to go a little while before you see a repeated pattern of things canceling. So make sure you see a repeated pattern and then you can cancel everything out and leave the terms that don't cancel. This series would converge to 1, but not all series will converge to just the first number. So be very careful when you're doing this. So notice we have a fraction here. We have 1 over 2n plus 1. You should also recognize that 2n plus 1 is always an odd number because I told you about that earlier, and that's something that you should be cognizant of as you go along. And so let's just simplify this a little bit. Let's plug in 1. And if I plug in 1, then I get 1 over 2 times 1 plus 1 is 3. 1 over 2 times 1 plus 3 is 5. So my first term would be 1/3 minus 1/5. And I'm not going to simplify it. I'm just going to keep going. Okay, my next term would be plug in 2. So 1 over 2 times 2 plus 1 is 1/5. And then 1 over 2 times 2 plus 3 is 7. And then my next term would be 1 over 2 times 3 plus 1 is 1/7. And 1 over 2 times 3 plus 3 is 1/9. So as you can see, all of these numbers after the 1/3 end up canceling out. So this series converges by the telescoping, I spelled that wrong, series test. And you can actually say that it converges to 1/3, but remember, most of the time you're not going to be able to say what it converges to unless it's a geometric series, like up here, or a telescoping series. All the other ones, they don't tell you what it converges to, they just tell you that it actually converges. Alright, so I've kept this video to less than 20 minutes. You have time now to enjoy your day, start your homework, and do the AP reviews if you haven't done so, because remember, they're due pretty soon. So I hope you have a good day. I'll see you in class. Miss you guys, and talk to you soon. Okay, bye.